Good day, viewers at home. I remain Engineer Will.i.am plus S. In our today's physics class, we shall be discussing motion and graph. So while describing motion and graph, there are few things you should know when you want to solve question involving motion or graphical motion. The first is that the slope of distance time graph. So if this is your y-axis and this is your x-axis, and let the y-axis represent distance and the x-axis should represent time. If you plot a graph of distance over time, the slope of this graph represents speed traveled by the object. So slope of distance time graph represents speed. The next thing you need to know is that if you have displacement time graph, if here is displacement and here is time, the slope of displacement time graph will now represent velocity. The slope of displacement time graph represents velocity. Then the third is, this is time in second and this is velocity in meter per second. The slope of velocity time graph will represent acceleration. So slope of distance time graph represents speed, the slope of displacement time graph represents velocity, and the slope of displacement time graph represents velocity, and the slope of velocity time graph represents acceleration of a moving object. Then another thing you need to know is that whenever you want to represent acceleration of objects or a car in a graph, so if here is velocity in meter per second and here is time in second, then acceleration is here is the rest position. This is at rest. If an object is here, the object is at rest, the rest position. So if an object accelerates from rest, you should represent it with this kind of line. So the line should start from rest and go upward. So this line represents acceleration. Then if an object moves with uniform speed, or you can say uniform velocity, meaning that the velocity is neither increasing nor decreasing. So if object moves with uniform speed or uniform velocity, you represent it with a line, horizontal line. So this means object is moving with uniform velocity or constant velocity. If you don't want to use the word uniform velocity, you can use the word constant velocity. So this represents uniform velocity. So uniform velocity goes horizontal. Acceleration goes like this. Then the last is retardation. So if an object retards, meaning that the object is reducing its speed or is gradually brought to rest, the slope or the line is going in this direction. So that is the things you need to know when you want to solve velocity time graph. Then if this is an object, this is a velocity time graph, velocity and time graph. So the shape formed by the joining, after you have analyzed your question, the shape formed represents the total distance covered by the object. The slope formed represents the total distance covered. So remember that from here to here, this vertical line represents the velocity and the horizontal line represents the time taken. Let us look at some questions so that we can make it more clearer. The diagram below shows the speed time graph of a car. If the car covers a total distance of 600 meters in 5 seconds, calculate its maximum speed. So if you look at the diagram, here we're supposed to have speed here, that is speed of velocity here. But in the diagram, it wasn't given. So there's no speed here. And we are required to find the speed. Like what I said earlier, If you want to get the speed just represents this vertical line, and the time interval represent the time taken, represent the horizontal line represent the time taken. So the height of this particular shape is the speed of the car. The height is the speed of the car. Remember, here is rest. So the total distance covered by this car, which is the shape, the area of this shape represents its total distance. So the area of this shape represents distance. So let us see how we can solve it. So what is the area of this shape? This shape is a trapezium, and the formula for area of a trapezium, is 1 over 2 b times h. So this is area. Then this represents one of the side. Let's say from here to here, that is your A. Then from here to here is your B. Then the h represents the height, which is the velocity. So we now have area. The area has been given already as the total distance. So the total distance traveled by the car is 600 meters. So we represent area with 600 meters, equal to 1 over 2 bracket. Our A will now be from here to here, which will be 20 minus 5, which will give us 15, plus from here to here, which is 25, multiplied by the height, which should be the velocity of the car. So that 600 will be equal to 1 over 2 bracket. This plus this will be 40, then bracket h. So that 600 will be equal to half times 40 will give us 20h. So if you divide both sides by 20, we have h is equal to 600 divided by 20. This will cancel this. We now have that h is equal to 30 meters per second. So the height, which is the velocity of this car, is 30 meters per second, which should be option A. Option A. I hope that is clear. Let's try another question. A car starts from rest and accelerates uniformly for 20 seconds. So we are going to represent it diagrammatically first. That is the first thing that should come to your mind. So this is velocity and this is time. So a car starts from rest and accelerates uniformly. So from rest should be here. It accelerates uniformly for how many seconds? For 20 seconds. So for 20 seconds, the time here should be 20 seconds. So here should be 0. For 20 seconds, to attain a speed of 25, so which means the speed here will be 25 meters per second. I hope that is clear. To attain a speed of 25 meters per second, it maintains this speed for 30 seconds. So that speed of 25 was now maintained for 30 seconds. So if you add 30 to 20 seconds, you are going to have 50. Total time spent now is 50. Remember, the first time used to accelerate was 20 seconds. This speed was now maintained for another 30 seconds, which if you add 30 to 20, you're having 50 seconds. Before decelerating, meaning that the object is now brought to rest. So it's now decelerate to rest. So decelerate is this particular line. And then I say that the total time for the journey is 60 seconds. So just add 10 to 50, which will give you 60 seconds. And we are now asked to, remember this is time in seconds. We are now asked to calculate the total distance covered. So what will not be the total distance covered? The total distance covered will not be the area of this particular shape formed. And this shape still remains a trapezium, which is area equal to 1 over 2 bracket A plus B, then h. The h is the velocity. So that area is equal to 1 over 2 brackets. What's our A? 50 minus 20, which will be 30, plus from here to here, which is 60. Then bracket, the h is 25. So area will be equal to 1 over 2 bracket. This is 90, then times 25. 90 times half will give us 45. 45 times 25 will give us 1125 meters. That is the total distance traveled by the car. So we have gotten the first question. The second question is to look for the deceleration of the car. Deceleration is this particular shape here. Remember, this is deceleration, this is acceleration. So if we are asked to look for acceleration, we use this particular triangle. But we'll ask for deceleration, so we're using this particular triangle because this represents deceleration. So our deceleration will not be the velocity, which is still the same thing, which is 25, divided by time for the deceleration, which is from here to here, which will now give us 10. From here to here is 10. That is 50, 60 minus 50, which will give you 10. But if you were asked to calculate the acceleration will not be 25 divided by the time, which is 20. So our deceleration will be equal to 25 divided by 10. If you divide 25 by 10, we have 2.5 meter per second square. That is the answer to the deceleration. We are going to take one more question on that, and I believe with that you will understand better. Last question. A car starts from rest and accelerates uniformly. So we are still going to draw our diagram. We're still going to draw a diagram. That is first thing to draw the sketch of the motion. This is your velocity. Remember, the unit is meter per second. And this is your time, which is in second. So a car starts from rest. So here is rest position. A car starts from rest and accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. So it reaches a velocity of, let's say here is 30 after 5 seconds. So here should be the time. After 5 seconds, full stop. It travels with uniform speed, the same speed as 30 this thing. It travels with uniform speed for 15 seconds. So you are adding 15 to 5. If you add 15 to 5, you are going to have 20. Then what happens next? 15, and is then brought to rest in 10 seconds with a uniform retardation. So after 10 seconds, it is now brought to rest. I believe that is clear. So here will be, here will be 30. Remember, the unit is time in seconds. So after 10 seconds, it is now brought to rest with uniform retardation. Determine, the first thing we have to determine is the acceleration of the car. Acceleration of the car. So how do you get acceleration? This line or this particular shape represents acceleration. Acceleration will be velocity over time. So what is the velocity? The height of the shape, which is 30. And what is the time for this particular speed? The time is from here to here, which is 5. So if you divide 30 by 5, we have 6 meters per second square. So this is the acceleration of the car. Then the next we have to look for is the retardation of the car. So the retardation of the car will not be this particular shape here. And what is the shape? So retardation will be A equal to V over T. Don't be confused with the symbol. The acceleration and the retardation has the same symbol. Just that you should know the portion of the triangle or the shape that is retardation and that is acceleration. So our retardation should be this particular shape. So which will not be, remember the height is the velocity, which is 30, then divided by the time, which is 10. So we have 30 divided by 10, which will now give us 3 meters per second square. That is the retardation of the car. The last is we have to look for the total distance. So total distance will be the area of the shape. What is the area? The area of this shape will be 1 over 2 bracket A plus B, then H. That is the area of the shape. So area will now give us 1 over 2. What is one of the side here? That is 20 minus 5, which will be 15. 20 minus 5. 20 minus 5 will give us 15. Plus B, which is the other side, which is 30. 30. Then the height of the object is the velocity, and the velocity here is 30 as well. So if you simplify this, you have 1 over 2 bracket 45. then 30, which will now give you, this will give us 22.5 times 30. If you multiply 22.5 with 30, we have 675 meters, and that is the total distance traveled by the car. I believe this is very clear. Thank you for watching. See you in our next class.